8th grade, 8.2.1. This is day 2. So this is kind of a shorter day, shorter lesson day. I don't know what I'm trying to say. Oh boy. Okay, scientific notation. That's what we're getting into today. I'm going to read 8-41, but we're going to keep this term in mind. 8-41 says, when astronomers describe distances in space, often the numbers are so large that they're difficult to write. For example, the diameter of the sun is approximately 1,390,000 kilometers, and then it writes it in kilometers. To make these large numbers easier to write, astronomers and other scientists use scientific notation. So it's a way to make large numbers easier to write. And there's some constituents or some rules that apply here. So in scientific notation, this is the diameter of the sun. So here's the sun. The diameter is the measurement across the face of it, the sun, or across the, no, it's across the face of it. Yes, because that's circumference. Okay, diameter is written 1.39 times 10 to the 6th kilometers. So that's what that's showing. That's the scientific notation. Part A, rewrite 10 to the 6th power as a single number without an exponent. What happens when you multiply 1.39 by this number? So here's what I'm going to do. Well, you could put it in your calculator, and if you were going to put this in your calculator, you would take your calculator if you're using your phone, turn it horizontally so it's long ways. You'd type in 10, then you'd click the button that says X, oops, that was a fraction. It says like X to the Y, and then put 6 and equals, and it will give you the value of 10 to the 6th power, which is 1 million. So now it's asking what happens when you multiply 1.39 by a million. Well, I know that I have the decimal, the kind of decimal shortcut or rule when you're multiplying by powers of 10, and looks like there's a bird out there. You will move the decimal to the right 6 times. 1, 2, 3, 4, 5, 6. You could also plug that into your calculator, and you will get the same thing. So if we do that, that becomes 1,390,000. So that's part A's answer. B says, in scientific notation, the mass of the sun is approximately 1.99 times 10 to the 30th power kilograms. What does this number mean? Discuss how to rewrite it without scientific notation and then write it. I didn't want to write this entire number out because it's just gonna, actually I did eventually write it out, and I guess I could, but okay, I'll write it out. I've decided. So it's gonna look like this. 1, 2, 3, 1, 2, 3, 1, 2, 3. How many groups of 3 do we have? 1, 2, 3, 1, 2, 3, 9 groups of 3. Oh boy, yeah, this is why I didn't write it down. And 1, 2, 3, 4, 5, 6, 7, 8. There should be 1 extra here. Okay, so that's how you would write out that number, because you're going to move that decimal 30 times to the right. So it's basically 199 with 28 zeros after it. Because you'll notice that the first two decimal points don't make any zeros. They just make 1.99 into 199. And then 28 more times, 28 more times would give you the amount of zeros. I'm going to go grab Bailey. 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 Come on. Come on, Bailey. Okay. There's 28 zeros. Don't move that. Okay. Wow, it smells like syrup. Okay. So that was the first problem. 842 says, scientific notation requires that one factor is a power of 10 and the other factor is a number greater than or equal to 1 but less than 10. For example, so let's back up. So a factor if you're multiplying two things together, the things that are being multiplied are called factors, and your result is called the product. If you remember that from earlier math courses. So now, it says scientific notation requires that one factor is a power of 10, which we've seen, and the other factor has to be a number that can be equal to 1 and greater than 1, but it has to be less than 10, so it doesn't include 10. So it has to be either greater than or equal to 1 or less than 10. So let's look. It says, for example, 2.56 times 10 to the 5th is correctly written in scientific notation because 2.56 is a number in between 1 and 10, and there's a power of 10 as the second factor. But 25.6 times 10 to the 4th is not scientific notation because it's a number greater than 10, and we can't have those in scientific notation. So now it also says scientific notation uses the x for multiplication. It doesn't use a dot. Okay, so we're not saying 2.56 times 10 to the 5th. Scientific notation doesn't do that. So now we're going to fix these ones that it's showing us if we remember these rules. Let's see. I'll leave that stuff. I'll say dot equals sad face, and then a multiplication symbol equals happy face. Okay, so it says, this is our first one that we're going to fix. 10 to the 4th. Okay, so let's see why doesn't this one work in scientific notation. And like Dora the Explorer, you can yell it out right now, and I'll wait. But it's a number greater than 10, like we just said. So we cannot have a factor right here that's greater than 10. So we need to make it into something that would work. Well, I could move this decimal to the left once to make it 2.56, which works out, times. Now this is going to change. Whenever you're moving the decimal point to the left in a scientific notation, you're going to bump this number up that many spaces, so it would be 10 to the 5th power. And then reverse it. So if you're going to the right, that would get smaller and smaller and smaller. Okay, B says 5.46 times 100. And first off, I see a no-no. The dot is sad face. We don't like it. so the dot needs to be fixed, but this number is okay. 5.46 works, so we're going to change the dot to multiplication symbol, x, and that has to be a power of 10. It can't be 100, it can't be written like this. It has to be a power of 10. So in order to write 100 as a power of 10, 10 to the what power will give us 100? Well, 10 times 10 gives us 100, so 10 to the second power would be our correct scientific notation. We'll finish that out. Okay, so that's good, that's good. Let's look at part C. 0.93 times 10 to the 8th. Okay, so this number I'm looking at, is it a number between 1 and 10? No, it's not. It is less than 1. This is 0.93. It's 93 hundredths. So I need to fix it. And we're going to fix it. Well, if I move to the left, I'm going to keep making it smaller and smaller, so that's not going to work. If I move it to the right, once, I notice I get 9.3, which works because that's less than 10, but more than 1. And we're going to change that exponent. So we move to the right this time. So the exponent is going to get smaller because this number got bigger. So that's going to be 7, 10 to the 7th power. So that would be the correct scientific notation for that problem, part C. Okay, so a little bit more practice. -43. Using this pen a lot. Write each number below in scientific notation. Okay, so now it gives us the big numbers, and we've got to write them out in notation. Okay, so I have 370 million. Here's how I do my scientific notations. I put the invisible, there we go, invisible decimal point at the very end, because every whole number has like an invisible decimal point at the very end where you can add zeros forever. So I'm going to move it to the left, because this is way too big of a number. I'm going to move it to the left until I get a number that is either 1, between 1 and 10, or less than 1. So let's try it. 1, 2, 3, still too big. 4, 5, 6, still too big. 1, 6, yeah. 7, 8. Hey look, I'm at 3.7 now. That is my magic number. Let's see, how many times did we move? I moved over 1, 2, 3, 4, 5, 6, 7, 8. Moved 8 times to the left. So that is how you would write 370 million in scientific notation. 48,710,000. Oh, oops, sorry, I read that wrong. Ooh, that's billion. 48,710,000,000. Okay, we've got to write this in scientific notation. Same idea. Invisible decimal point comes alive. Now we're going to move to the left until we reach a number between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Almost there. 10. 4.871 is my first factor, because that works between 1 and 10. And how many times did we move to the left? I think it was 10 times. So 10 to the 10th power would be the correct power of 10. So that is how you write really, really big numbers so that they're easier to write. Last problem, we're talking about planets, because when we're talking about space, we're usually talking about things that are really big and far away. Okay, so it says, scientific notation makes large numbers easier to write. It also provides you with quick information about the sizes of the numbers. For example, Pluto and Haumea are both dwarf planets. Pluto has a mass of 1.305 times 10 to the 22nd kilograms. Haumea has a mass of 4.006 times 10 to the 21st kilograms. Without rewriting the mass of each planet, can you tell which one of these is going to be larger? Which planet is larger just by looking at the scientific notation? And I'm looking at the exponents, or I'm looking at the power of 10 that I have for both of them. So my exponent here is 22. My exponent here is 21. This means that this one's going to have an extra 0 at the end, and this one's going to have one less 0 at the end. That means that Pluto would be bigger. That would be the bigger planet. And you can tell by the exponent. The bigger the exponent, the bigger the number. So Pluto wins, Bailey wins, and we all win. Goodbye.